Lesson 4. Implement path control using policy-based routing. Path control using PBR. PBR provides a flexible, powerful, and simple tool to deploy solutions in cases where political, contractual, or legal constraints necessitate that traffic be routed through specific routes. Just want to let you know that PBR is a very flexible, simple, yet powerful tool to deploy solutions in the cases I just listed in this slide. So basically, we're gonna see in the upcoming slides how we can use PBR to define a routing policy other than basic destination-based routing using the routing table. PBR configuration, we use the route map command to define and name the route map. So we can define the action to be taken when there's a match by using the set statements, and we can use the match statements to define the conditions to match. I just want to let you know that Cisco Express Forwarding switch type of PBR is enabled by default in the recent Cisco Internetwork operating system versions. We can also define and specify which interface the route map will be attached to by using the IP policy route-map interface configuration command. And remember that PBR is always applied to incoming traffic, the packets that are coming into the router, not the ones that are going out. PBR route map commands. What I'm showing you here on the slide are the parameters for the route map commands. So we have, for example, the map tag that specifies the name of the route map. We have permit and deny that specifies the action to be taken if the route map match conditions are met. We have the deny that denies match route from being redistributed, and permit that actually permits the very same match routes to be redistributed. We also have sequence numbers that specify and indicate the position of the sequence number when a new route map statement will have in the list of route map statements if it's already configured within the same route map name. And when it is used for redistribution filtering, route map is applied to the route distribution process by adding the route map command and map tag to the end of the redistribute protocol command. Here we have the match and set commands, the match condition commands, as you see. So once inside the route map configuration mode as designated by a router prompt, we can enter the match command to specify criteria to be matched. So in this case, the match condition route map configuration commands are used to define the conditions to be checked. And some of those conditions are used if you want for redistribution filtering. Some are used for PBR, and others are used for border gateway protocol policy. Match IP address command, and this is the command that you see in here. It's a match IP address access list number name, access list number name, prefix list name, prefix list name. So basically the access list number name, the number or name of a standard or extended access list to be used to test incoming packets, while the prefix list name specifies the name of a prefix list to be used to test packets. The match links command is match links max. So we use this command to establish criteria based on the packet links between specified maximum and minimum values. For example, you as an engineer can use the match links as the criteria to differentiate between transfer and interactive traffic, because file transfer traffic usually has much larger packets. The set statements, we use a set action command. So once a match has been made, the set commands are used within a route map to add or even change, if you want, metrics to any routes that have met the match criteria. Here we have the set IP next hop command. So we specify the next hop IP address for matching packets by using set IP next hop IP address IP address. If more than one IP address specifies, the first address is associated with a currently up connected interface is used to route the packets. The first command will route the packets. We can also set the interface commands. So we specify interfaces through which packets can be routed by typing set interface type number type number. Now, if there is no explicit route for the destination address of the packet in the routing table, the set interface command has no effect whatsoever and is ignored. So keep it in mind so your configuration won't go ineffective at work. A default route in the routing table is not considered an explicit route for an unknown destination address. This is a major common error out there. Set IP default next hop command, set IP default next hop IP address, specifies a list of default next hop IP addresses. So a packet is routed to the next hop specified by this command only if there is no explicit route for the packet's destination address in the routing table. Also, a default route in the routing table is not considered an explicit route for an unknown destination address. I'm saying it again so you don't make that mistake on the exam. We can specify a list of default interfaces by setting a default interface command using the following command: set default interface type number type number. Again, a packet is routed to the next hop specified by the set default interface command only if there is no explicit route to the packet destination address in the routing table. I said it 3 times, don't make that mistake. Set IP TOS command. To mark packets using the IP TOS field, we type or we use the following command: set IP TOS name number. So the TOS feed in the IP header is 8-bit long with 8 bits for setting the class of service, and 3 bits for the IP precedence. And the CIS bits are used to set, if you want, the cost, reliability, throughput, and delay. Show IP precedence command is set IP precedence name number, and we use it when implementing quality of service and can be used by other services as well, such as the weighted random early detection in the weighted fair queuing. Now, we have 8 possible values for the IP precedence. Values 0 through 7 are defined. You know, when we start with 0, end with 7, we start counting with 0, so we're talking about 8 possible values, as 0 is a possible value. Configuring PBR on an interface. So we use it to identify a route map to use for policy routing on an interface by typing the command IP policy route map tag. So remember, the map tag parameter is the name of the route map to use for policy routing, and it must match a map tag specified by a route map command.